In this lesson, we're going to talk about frequency tables, and levels of measurement. These are ways, again, that we can organize and categorize the data. We're going to first talk about the levels of measurement, and it's important to understand the levels of measurement because correct statistical procedures depend on a researcher being familiar with the levels of measurement, because not every statistical operation can be used with every type of data set. So you have to be familiar with the different categories and the different levels of measurement so that you can apply the correct statistical procedure. Now, there are 4 levels of measurement that we are going to talk about, and they're listed here in the notes in order from lowest to highest. And the first 2 categories and the last 2 categories are very much related. The first 2, the lowest, is called the nominal scale. The next one is called the ordinal scale. Now, these both are levels of measurement that you would use for categorical data, so things that you would put in categories. The difference between the two is that the nominal scale level deals with data that has categories that don't necessarily make sense to put them in a certain order, where the ordinal scale does have a way that you can place them in order so that it makes sense. So, for examples for the nominal scale level is like colors of cars and food groups. The example that I'm going to use is colors of cars. If I go through a parking lot and I list all the colors of the cars that I see in there, white, black, red, blue, green, okay, there's no specific order to the colors that makes sense. Maybe that person has a personal preference on the colors that they like and they can rank them that way. But in general, it doesn't make sense to rank red higher than blue or vice versa. So colors of cars and those kind of categories that cannot be listed from smallest to largest in any way that makes sense, that is called a level of measurement that is nominal. Now, if you have categories that can be listed in order that has some kind of meaningful definition to be listed that way, that is something that is called an ordinal scale level. So an example of that, and I have that listed down here, is titles at your job. So we have, if we're talking about education, we have instructors, we have lecturers, we have assistant professor, associate professor, and then full professor. Those are categories, but you can also rank them from lowest to highest. Instructor would be the lowest, and then the full professor would be the highest. So they're categories, but they can be ranked. So that is an example of data that has a level of measurement of ordinal. Now, if we scroll down and look at the next 2 categories, that is the interval scale and the ratio scale. Now, these levels of measurement are levels of measurement that deal with numerical data. Now, the difference between these 2 is that the ratio level of measurement has what's called an inherent zero. So that means the number 0 would literally mean none in that example. So you're probably thinking to yourself that, well, that's how I think of 0 anyways, is none. But if you think about it, if you think of temperature, which is a perfect example, if I talk about 0 degrees Fahrenheit, that doesn't mean that there's 0 temperature. That doesn't mean that there's no temperature. There is a temperature. It's just that that 0 is used as a placeholder on a scale. That doesn't mean that there's 0 temperature. Okay, so there is a difference between an inherent 0 and a non-inherent 0. So the interval scale is data that can be ordered and that the differences between the entries can be calculated, and that but with the 0, that means it's really just a position on a scale. With the ratio level, the difference between the values can be measured. It can be listed from smallest to largest, but the 0 in the ratio scale literally means nothing. So an example of that might be money, weight, and exam scores. If you have 0 money, that means you have none. It's different than if you say you have 0 degrees Fahrenheit. That doesn't mean you have no temperature. It's a placeholder on a scale. Okay. If you have 0 weight, that means there's no pounds or no ounces. Exam scores, if I say I've got a 0 on an exam, that means I have no points. Okay, so that's the big difference between the interval scale and the ratio scale. They both deal with numerical values, but one has an inherent 0 and one does not. In the second example, we are going to go over how to organize data in a frequency chart. And we'll be using frequency charts quite a bit later when we get into chapter 2. And the first thing you need to discover is you need to find the class width. This chart depends on the class width, and the class width tells us how wide the interval is going to be when we break it up into groups. And the groups are also called classes. So we're going to have 4 groups here, 4 classes, and so we want to determine how wide that class is going to be. So we need to find the maximum number, subtract the minimum number, and then divide by the number of classes. This is our general formula for finding the class width. Now, for our specific example, our maximum number, if you look at all the values in this data set, the highest number we have is 182. The lowest number we have is 152. And since we're trying to create 4 groups or 4 classes, we're going to divide by 4. Now, when we divide this in on our calculator, we're going to get 7.5. And we always want to round up to the nearest integer. We always round up, even if this came out to 7.1, we still want to round up to 8 because we want to make sure that there's enough room in the interval so that we can fit all the numbers. And also, even if this number comes out to be an even number, like it came out to be 7 exactly, we still want to round up to the nearest integer, again, to make sure that we have enough width in each of those intervals to contain all the numbers. Okay, so now that we have our class width, what this tells us, in each of my categories, I want 8 numbers. Class limits will help us first determine how we're going to organize the groups, and then the class boundaries will be what we use later to graph a histogram. Okay, so to start off, to find your first group, you're going to start with your lowest number, which we said was 152. Now, we want 8 numbers in this group. So 152 is included in this group. So I want 152, that's the first number. I want a total of 8, so I want 7 more numbers. So I'm going to take 152 and add 7, and I'm going to get 159. This will give me a total of 8 numbers, and you can count it on your fingers to check, because intuitively you want to take 152 and add 8, but what you got to realize is we're including that 152 in our group of numbers, so we want that first number plus 7 more for a total of 8. Then when you create the next group, you want to jump to the next integer, so we're going to jump to 160, and again we want 160 plus 7 more numbers for a total of 8. So I'm going to add 7 to this, and I'm going to get 167. Then I'm going to jump to the next number, which is 168, add 7 more, that's going to give me 175. Then for the last group, I have 176 to 183. Now, for the class boundaries, we're going to use this later when we're graphing a histogram. Statisticians do not like spaces between the bars of a histogram. So if you notice there's a space, if we use the class limits as our bars, we go from 152 to 159, there's a space, and then we go to 160. So the space between 159 and 160, we want to close that gap, because there's numbers in between there like 159.3, 159.7. There's numbers between the 159 and the 160. So to close the gap, when we look at our class limits, we're going to come out a half to the left and a half to the right. And that's going to help us close the gap. So I'm going to write this as 151.5 to 159.5. I'm adding a half to the side of each of those limits on that interval. Now when I go down and do that for 160, if I come a half to the left, that's going to give me 159.5, and if I come a half this way to the right of 167, that's going to give me 167.5. Now notice there's no gap from interval to interval. It ends with 159.5 and it starts with 159.5 on the next interval. For the next interval, if we keep up that pattern, we have 167.5 to 175.5, and then we have 175.5 to 183.5. Now the midpoint, we're going to use this later to graph a frequency polygon. So this is all the ways that we're organizing the data so that we can later graph it, or we can see where the certain concentrations lie. Okay, now to find the midpoint, let me write this up here. You want to take, and I'll abbreviate, lower boundary, LB for lower boundary, plus the upper boundary, and you divide that by 2. That's how you're going to find your midpoints. So this right here is my lower boundary, and then this right here is my upper boundary. So I want to add those two together, 151.5 plus 159.5, find out what that value is, and then divide by 2. And you're going to get 155.5. And you're just going to do that all the way down. So the next one, I'm going to take 159.5 plus 167.5. I'm going to add those together, divide by 2, and I'm going to get 163.5. If we continue that process, our third midpoint for the third class is going to be 171.5 and then 179.5. Now, for the frequency, what we're looking at here is like this box right here. I'm trying to find the frequency for the first class. So what I'm doing is I'm trying to find how many values lie between 151.5 and 159.5 in this data set. So you're going to go ahead and count and go through and find all the values that lie between 151.5 and 159.5. When you do that, you're going to find that you have 8 values. Then for the frequency of the second class, you're going to go through and count how many values lie between 159.5 and 167.5. Go through and count all those data values, and you're going to find that you have 9 data values. And you're going to continue down and check to see how many of these values lie on each of these categories. So for the third category, you're going to have a frequency of 5. And for the last category, you're going to have a frequency of 3. Now, let me show you how you can organize this data on your calculator to make it easier for you to count and you don't miss any data values that way. So, to put data values in your calculator so you can sort them, which will make it easier for you to count, the first thing you're going to do is hit this stat button here. And in this list under edit, the first option says edit, and that's where you enter all your data values. So I'm going to hit enter on edit. And then you pick one of these lists to enter your data. Now, if you want to use list one or a certain list and you already have data values in there and you want to clear them out, what you can do is use your up arrow to highlight the list, and then you're going to hit clear and then enter, and that will clear all the values all at once. Then what you're going to do is enter your values. So you're just going to, if you want to enter 159, you just hit the 159 button and then enter. And then if you want to put in 161, you put 161, enter. And you go ahead and do that for each of the data values until you have all the values listed. So go ahead, pause the video, enter your values, and then restart the video. Now that you have your values entered in list one, there's a couple things I want to show you. If I go up and say I highlight this 165, notice at the bottom it says L1 and then in parentheses 24 is equal to 165. This notation means the cursor or you're highlighted in the L1 list and you're sitting at the 24th entry. And this is nice because if you come down here and highlight your last entry, you can see that last entry is 25, and that way you can check to make sure you got all your data values. If my last entry said 24 and I know I have 25 values, I know I missed one and I can go back and check. This is really handy. All right, now once you have your data values in there, what we're going to do is we're going to sort it. We're going to tell the calculator to sort it from lowest to highest. So I'm going to hit the stat button again. I'm going to arrow down to number 2. It says sort A. There's two different sorts here. There's sort A, and then number 3 says sort D. Sort A is sort ascending, which means it's going to go from lowest to highest. And sort D is sort descending, which means it's going to go from highest to lowest. We're going to stick with number 2, and then I'm going to hit enter, and then the calculator is going to wait for you to put what list the calculator needs to sort. So if you notice, we need to tell the calculator to put it to sort list 1. So if you notice above your 1, 2, 3, 4, 5, 6 buttons, you have your list options, and it's going to be in a different color. So above my 1, it says L1. Above my 2, it says L2. Now your calculator is color coordinated. So when you need to access one of these shift options, you want to make sure, since this is in blue, my L1, I want to hit my blue shift button first. So that's this button here. If it's something that's in green, I want to make sure I hit this button first. So make sure you're choosing the correct button when you need to do a shift. So I'm going to hit second 1 to access my list button for list 1. And then I'm going to close parentheses, and then I'm going to hit enter. It's going to say done. And now when we go back into the list, it's going to have everything sorted from smallest to largest. So I'm going to go back into the list by hitting stat. I'm going to choose number 1, edit. And you can see that everything now is sorted from smallest to largest. Now this is where it's going to make it a lot easier to start counting so you don't miss anything. We want to count how many values lie between 151.5 and 159.5. So they scroll down, since they're in order, it makes it much easier to count. So I'm going to count, there's the first one, 2, 3, 4, 5, 6, 7, 8. When I get to the 9th one, I get over 159.5. So I know I stop at 8. I've got 8 values that lie under 159.5. Then I can go to the next grouping. The next grouping is anything from 159.5 to 167.5. And then I can continue to count down again until I get out of that range. So this makes it much easier instead of just trying to eyeball it on a paper, and that helps you not miss a value when you're counting. So let's go back to our notes. Now, when we look at the relative frequency column, what we're doing is we're looking at each interval and finding, instead of the counts, we're finding the proportion of values that lie on that interval. And since there's 25 total data values, for the first interval, we would have 8 out of 25, which we can write as a decimal as 0.32, or we can say 32% of the values lie on that first interval. And we go down and do that for each frequency. So the second interval would be 9 out of 25, which would be 0.36 or 36%. So we just go down and do that for each of these intervals. And there you go. So for the cumulative frequency, what we're doing is we're adding up the accumulated frequencies for each row. So when I look at the first row, the frequency for the first row is 8. So I put an 8 here. When I look at the second row, I want to add up all the frequencies up to that row. So I would add 8 and 9. So that would give me 17. Then I would add in 5 on the next row, which would give me 22. And then I would add 3 in on the last row, which would give me 25. Now this value should always add up to the total number of data values that you have. Otherwise, you missed a value somewhere, you made an error. Now we can use this chart to later make graphs, which we'll get into in chapter 2, but we can also use it to answer some basic questions because the data is organized now. So in part A, it says find the percentage of hikes that are from 160 to 167 centimeters. So that is the second row, and the percentage, which is from the relative frequency, when we look at that row, we can say there's 36% of the values lie between and on 160 to 167. So we're including the 160 and the 167, and then all the values in between. So this would be 36%. Now, for part B, it says find the percentage of hikes that are more than 168. So more than 168 would be everything in the last 2 rows. So I would have to add up those percentages. So there's 20%, which is 0.2 of the decimal. There's 20% in the third row, and then 12% in the last row. So that gives me a total of 32%. So 32% of the values are above or at 168. Okay, the next part says find the number of players in the sample who are between 176 and 183. So 176 to 183, that's the last row, and it's not asking for a percentage here, it's asking for the number of players. So that's the frequency. There are 3 data values that lie in that interval, and each of those data values represents the height of one of the players. So this would be 3 players. The last part says, what kind of data are these hikes? This would be quantitative. And just as a nice review, if we're talking about the level of measurement, we would call this a level of measurement that is ratio because this has an inherent 0. If you say you have 0 centimeters, that literally means there's no height. So you have that inherent 0.